Java's multithreading feature allows developers to write concurrent programs, leading to better resource utilization, improved performance, and responsiveness. However, defects arising from multithreading issues such as race conditions and deadlocks are extremely difficult to detect and debug due to their dependence on the non-deterministic scheduling of concurrent threads by the underlying OS. In this video, I will demonstrate an intentionally created multithreading defect in a sample e-commerce application called Heat Clinic. Note that to get this multithreading defect to occur, I will create few virtual users using a small Java program. Then, I will show how Seagence accurately detects the demonstrated multithreading defect, including the root cause, and complements Datadog. As shown in the code, the defect is introduced in the endpoint that adds an item to the cart. The readMessage method, which loads messages from a resource named siteMessages XML file, uses a class-level static variable of type document-builder as a shared resource which is not thread-safe. So, when requests are received and executed by parallel threads, there is a good chance that some requests fail inside the readMessage method. Additionally, the exceptions raised by the document-builder object are swallowed by the catch block instead of being reported. In the Java program that creates virtual users, I have an executor service with a pool of 8 threads parallelly dispatching 150 add item to cart requests to the Heat Clinic application. These many virtual users are good enough to produce the multithreading defect in the application running on the local Windows machine. Now, I am going to run this Java program and wait for its completion. Now the program has been completed. Since both Datadog and Seagence are already monitoring this e-commerce application, and Seagence integration with Datadog is enabled, let us see how Seagence complements Datadog. In Datadog's Traces dashboard, you notice that Datadog has reported all of the recently executed 150 add item to cart requests as successful. Now, let us explore Seagence detection. In Seagence integration dashboard, a red vertical bar appears, representing failed add item to cart operation detected by Seagence. You can also find the root cause exception of the defect, which is null pointer exception with the complete stack trace. Notice that this exception is raised inside the readMessage method while the non-thread-safe document builder object is parsing the XML file. This defect can also be viewed in Datadog's Events Explorer with context and complete stack trace of the root cause exception. When Seagence reports a defect to Datadog, a preconfigured monitor will automatically notify you. Seagence provides traces for all defect transactions, success transactions, and context for all requests on Seagence Web. In the Clusters tab, you will find traces grouped by the similarity of the transaction execution. These groups are called clusters, and Seagence grouped 6 occurrences of this multithreading defect into one cluster, and highlighted in red. Clicking a cluster will list all traces, and expanding a trace will list all exceptions thrown during request execution. You see that few occurrences failed with null pointer exception and few occurrences failed with X and I exception, which is a common symptom in multithreading defects and makes debugging confusing and more painful. However, Seagence could still detect this intermittently occurring multithreading defect with accurate root cause and group all occurrences of the defect into a single cluster. Seagence also excels in detecting hidden defects caused by swallowed exceptions, caught exceptions, and misdiagnosed 500 errors, among other things, and complements Datadog and other APM and observability tools. Interested? Sign up for a free trial and see it for yourself.